Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello dear students, welcome back to this TV learning series program. I'm Teacher Patrick as usual, and I'm privileged to be with you once again. And today I will be taking you through Chemistry Senior 1. So I expect you to be ready, and I'll just give you some few seconds. Get your pens and notebooks, and we are going to look at Unit 4. And this is about pure substances and mixtures. So in the previous unit, you could have looked at matter. And when I talk about matter, by this time in Senior 1, I expect at least all of you to have some information about what matter is all about. And when we talk about matter, matter is anything. When you say anything, either in liquid form or solid or gas or plasma that can occupy space and has weight or mass. So look around yourself. Look around where you are seated now. What can you see? Probably you can see some chairs, you can see some plates, you can see whatever that is around you. So can you tell whether that substance is pure or is a mixture? So when I talk about mixture in a layman's understanding, I think it is clear that a mixture is a substance with different materials or components put together. So can you tell that those substances are either mixtures or pure substances? Well, it is not very easy to tell whether substance is pure or is a mixture. Or sometimes there are some mixtures that you can easily tell, but there are some that you may not. A pure substance is the one that contains only one material or component. Pure substances are hard to get in nature. Give an example when we talk about pure water. When we say pure water, that's one of the examples. When we say pure water, it is very difficult to get pure water. But when we're talking about pure water, that means it contains only hydrogen and oxygen, and there is no any other substance that is mixed with it. Or you can give other substances that you may think also exists in nature as pure substances. Well, let's give another example. You can have gold. Gold is an element in its, even that it is found under the earth crust, but it is found in its pure form, not mixed with any other substance. So you can talk about gold, you can talk about mercury, can talk about even other elements. You can talk about even copper and etc. These substances they may be in pure form. Even other elements that you may even be knowing, they exist in pure form. But when you look at them physically, for example, if I look at this beaker, this is an example, I can't easily tell whether this beaker is a pure substance. The only way to tell that this is a pure substance is by determining some characteristics. So pure substances have got specific characteristics. For example, if we are talking about the pure substances, if you want to tell that this substance is pure, then there are some experiments that have to be carried out. For example, you need to determine that the boiling point and the melting point. If you cannot, if these melting point and boiling points are determined, these are the ones that can tell you that this is a pure substance. Because pure substances have got definite boiling and melting points. So that is how you can tell this is a pure substance. That is one. Two, you can determine the density of the substance. The density of the substance. If the density of the substances is determined, then you can easily tell, because densities, pure substances have got specific densities. For example, you can't easily tell what kind of liquid is this. If I look at it, I may think probably it is water, but probably it may not be water. So you need to determine the boiling point of this liquid to confirm whether it is water. So that is how you can tell that this is a liquid, and liquid water. And again, you need to determine the density, because we are aware that the density of water is 1 cubic centimeter, 1 gram per cubic centimeter. So if you determine the density and you find it is 1 gram per cubic centimeter, then you can easily confirm actually that this is liquid water. Then another substance, another characteristic that you can use, you can also find the freezing point. The freezing point of the substance. In case if the substance is a liquid, then you can also determine the freezing point, because also the freezing liquid substances also have freezing points that are definite. So that is how you can tell that this is a pure substance. But in nature, as I said, it is very difficult to find pure substances, though they exist, but it is very difficult to find. Now, as I said earlier, that matter is everything. So matter is subdivided. So when we talk about the matter, it can either be pure or impure. That is, if we say matter, then this one can be divided into pure substances or impure substances. So these impure substances, so we have mentioned already the pure substances. So these impure substances are called mixtures. So we have briefly talked about the pure substances, and then we have mixtures. Very different types of mixtures. So mainly, the mixtures are categorized into two. So we have either, the mixtures are either homogeneous, or heterogeneous mixtures. So there are two categories of the mixtures, homogeneous or heterogeneous. So we said the mixtures are impure substances. For example, if I have, so we are just going to look at what are the homogeneous substances? What are they? If I have this, I said this is the water, and then I mix it with this is another liquid. So when I mix this liquid and put water, these are two liquids. This is hydrochloric acid, this is water. This is a mixture of two liquids. This hydrochloric acid, it is also a liquid form. This one is also a liquid, which is water. So when you look at this forms a homogeneous. What do we mean by homogeneous? A homogeneous, these two components, they may be two or more than two components which we have here, are uniformly distributed. So you can't separate. You can't tell. If you look at this mixture, for example, you can't easily tell that this is a mixture that contains two components. So it is uniform. Now, this is one of the examples of homogeneous mixtures. Now, here I have even, this is vinegar. Vinegar is added into, usually when you're making salads, usually add vinegar. It is also a colorless liquid, and as I said, this is water. So I add water. This mixture is uniformly distributed. So you can't separate these ones, you can't look at them and then easily tell that this is a mixture, because they are uniformly distributed together throughout the solution. So we can have, that is one of the examples of the homogeneous mixture. So the homogeneous mixtures can be, if we have homogeneous mixture. So this can be either liquid, where we had vinegar, which is in liquid form. We have where we've put water, which is also in liquid form. So that is liquid. We may have, we had some other example. We may have even solid, either solid liquid mixture. In the solid mixture, let me just show you an example of that one, where we have a solid. So if you have, for example, this is a compound of iron, I just want to dissolve, just put it in water, I just put there some little water. So this is some compound. So I have to dissolve. So when you dissolve this substance, this substance is dissolving completely, and you can easily see that it is disappearing. So this was in solid, and this we are just putting it in liquid. So we said solid liquid mixture. Look at this one. So the solid that I put there has disappeared. So that is solid liquid. So the solid which I've put here, the solid which I've put in this liquid. So here, after dissolving together, we make what we call a solution. So this makes a solution. And the solution is made up of two components, two special components, where you have a solvent and then you have a solute. You have solute and solvent. So the solute is this substance that we had put here. So that is, the solvent is the water that dissolved the solvent. So that is, now we may have that one as also an example. We may also have gas mixture. Can you suggest maybe one example where you have mixtures? Gas. So we can have either maybe air. So we have air, maybe nitrogen. We have nitrogen, oxygen, and then carbon dioxide. So that could be gas mixture. So we may have either liquid, solid, and other mix. So those are some of the examples that we are giving which are homogeneous. The homogeneous, even we mentioned the liquid, and we gave some examples. So let's talk about the heterogeneous mixtures. So in the heterogeneous mixtures, you may have two components. Heterogeneous mixtures is made of two components. And evenly distributed. So these components are not evenly distributed. So it is the opposite of the homogeneous mixtures. Now let's look at the examples. Let's have some of the examples. Here I have oil. This is cooking oil. Everybody is familiar with the cooking oil that you use for cooking, frying, whatever you're cooking at home. So if we mix it with the water, that's an example. We're just going to use water as an example. So we mix it with water. Let me use some small one. Can use this test tube. And then we mix it, just put some little water. And then put the oil. I've said this is the oil. I don't know whether you're seeing what is happening here. I can even add more water. You see what is happening. So this substance is forming two phases. There are two layers. There is this upper layer, and then there is this lower layer. This is the lower layer is the water, and this is the oil. So this one, the upper layer makes the oil, and the lower layer makes the water. Why do you think the water goes down? Can you suggest why the water goes down? Good. So the water is heavier, is dense. So that is why it goes down. So we also call this mixture, apart from being heterogeneous, this is one of the examples of even heterogeneous mixtures. So it is also called immiscible. These are immiscible liquids. So you have oil and water. So this makes immiscible or immiscible liquids. Immiscible liquids. So we can have some other examples of this. We may have, here I have paraffin. This is paraffin liquid. These are some of the examples that we are giving as heterogeneous mixtures, but which are in liquid form. So this is paraffin liquid. And then I will have to add water. It is the same. So you see, it moves up. This is the layer that forms here. Just have a look at this. This is the layer which stops here. Then there is water here. So it forms layers. So we have another example here. We can have paraffin liquid, and water. This is one of other examples that we can have that form layers. They are immiscible and they are heterogeneous. Let's have more examples. So we have, this is methylbenzene. Methylbenzene is also an organic solvent. We can use it to test, rather to see whether it mixes with water, whether it is heterogeneous or homogeneous. So with water, we add water as well. We can even shake and then see what happens. So you see, as you shake, there will be even layers trying to separate. You see? So the methylbenzene is moving up, so it forms a layer. So that is one other example of methylbenzene with water. These are all miscible liquids. Those are some of the examples. So in the homogeneous mixtures that we have seen, if you remember, do you remember the examples that we give under homogeneous mixtures? We gave water. Here we had water and hydrochloric acid. That is, this formed a homogeneous mixture. But I can even give another example. So we had even vinegar and water. That was one example. We had the vinegar and water. But we can have another example where we have, this is an alcohol. This is methanol, one of the most dangerous alcohols. It causes, when you drink this, you're not supposed to drink this alcoholic anyway. As long as you are under age of 18, you are not supposed to take alcohol. And this alcohol specifically, the alcohol that we talk about that is put in alcoholic drinks is not this methanol. It is ethanol. But this methanol is very poisonous. When you drink it, it causes immediate blindness and even death. So very dangerous. But here we just want to use it as an example of the mixtures which are homogeneous. So that is the alcohol there. And then we add water in it. So you see there is no layer, that is uniformly distributed. Uniformly distributed. So you also have either, it can also be ethanol and water, or methanol and water, or any other type of alcohol, the common alcohols that we use. Now, these are two examples of the impure substances, which we said they are mixtures. So what is a mixture? So a mixture is made up of more than one component. So when we talk about the mixture, a mixture is made up of more than one component. Which are not chemically combined. They are not chemically combined. So they are physically combined. That is a mixture. So it means if they are physically combined, it means you can use a physical method to separate them. For example, if I have this is sand. This is sand. This is another example of if I put the water here, this makes even a mixture that is heterogeneous. Different, say this is solid liquid. This is, so this one can be easily separated because sand does not react with the water. So they just mix. So you can only separate this one by using the physical means. You don't need to use the chemical means. So that is why we are saying that there are mixtures. There is a mixture that contains more than one component, and they are not chemically combined. By just using simple physical methods, this can be separated. Can you suggest probably the method that can be used to separate this? Well, we use a simple method, and we are going to look at that method. It is just a simple one where we have, this is a filter funnel, and you have, you can use a filter paper like this, or even at home, if you have a mixture, if you want to separate, you have maybe water which is muddy, which looks muddy. Then you can use even some method, which is the filtration. You just filter, and then after filtering this, then you can easily you can separate them. But that is the physical means. When you are filtering, you are using the physical means. So the method of separating these mixtures depends on the nature of the mixture. And there are a number of methods that we are going to look at next time. We will be separating very many mixtures together. So I wish to stop here, but before I wind up, can you please take note of this exercise as homework? So you give at least 3 examples of pure substances. And say you have to state the factors that determine the purity of substances. And then number 2, you have to define homogeneous and heterogeneous mixtures using examples. So that marks the end of our lesson today. I hope you will be together. I wish you the best. See you again. Bye.